Okay, here in example 3, we're going to have to draw pictures in order to figure out what the value is, because we're going to be dealing with things that are either algebraic, meaning involving variables, or that they are not unit circle values. And so this first problem would fall into that second category. Notice that 2/3 is not a unit circle value, and so therefore I'm going to have to draw a picture to try and figure this out. And so it's important that you get your picture in the right quadrant, because this is arc cosine of a positive number. That means that I'm going to draw my picture in quadrant 1, drop a perpendicular down to the x-axis, and then put your angle right there next to the origin. And what arc cosine of 2/3 really means is to make the cosine of this angle 2/3. And so remember, cosine is adjacent divided by hypotenuse. And so on the adjacent side, we're going to put 2, and on the hypotenuse, we're going to put 3. And then we're going to find the other side using Pythagorean theorem. So if you want to just call it something for a second, like for example A, just to set up the Pythagorean theorem, then that's perfectly fine. So we're going to have the side squared plus the side squared is equal to the hypotenuse squared, and so this is going to be 4 plus a squared is equal to 9, which means that a squared is equal to 5, which means that a is equal to the square root of 5. And so what I'm going to do now is I'm going to erase this a here, and I'm just going to replace it with the square root of 5. Okay, so that takes care of the inside part. The inside part tells me how to draw my picture, and so now I'm going to do the outside part, which says tangent. And I know that tangent is the opposite divided by the adjacent. And so therefore, looking at my picture, my angle is right here. The opposite side is the square root of 5, and the adjacent side is 2. And so therefore, this is going to equal to the square root of 5 divided by 2. Okay, here in example B, looking at the inside, we have arc sine of -3/5, which is not a unit circle value, and so therefore I'm going to have to draw a picture. Arc sine of a negative number is going to end up in quadrant 4, and so I'm going to draw my picture in quadrant 4. Now, we want the sine of this to be 3/5, and so that sine, we remember, is the opposite divided by the hypotenuse, and so this is going to be opposite, which is 3, over hypotenuse, which is 5. But the question is, where did this negative go? Well, pay attention here. This 3 is on the negative side of the y-axis, and so because of that, we're going to put the negative on our 3. The negative will never go on the hypotenuse. The hypotenuse will always be positive, but the x or the y could be negative depending on what quadrant you are in. And so now we are ready to find this third side. I'm just going to call it a for the time being until we can solve for it. And so this is going to be a squared plus -3 squared is equal to 5 squared. And some of you might have been able to figure this out because of it being a Pythagorean triple, and that's perfectly fine if you understand that, but otherwise you're going to need to solve for it like I'm doing here. And so a squared is equal to 16 means that a is going to equal to 4. And so I'm going to erase my a here, and I'm going to replace it with a 4. And now I'm going to do the cosine of this angle theta. And so cosine, I know, is adjacent divided by hypotenuse, and so therefore the adjacent side of this is going to be +4, and the hypotenuse will be +5, so that we get 4/5 as our answer. Okay, here in example C, we're going to be dealing with something that is algebraic, meaning that the argument here is a variable x, and so we're going to do the same thing. We're still going to draw a picture. It's just that now things will be in terms of x instead of in terms of numerical values. And so looking at the inside here, arc cosine of x, and so what we're going to do is draw a picture, and we can just assume that x is positive here. And so that means we're going to put this into quadrant 1. And so here's our angle theta right here by the origin. And so we want the cosine of theta to be x. Or another way to think about that is x over 1. And so if cosine is the adjacent over the hypotenuse, that means I want my adjacent side to be x, and I want my hypotenuse to be 1. And so once again, I'm going to call this side a just temporarily until I can solve for x. And so, or to get a. So a squared plus x squared is equal to 1 squared, which is just 1. And I'm going to solve for a here. So a squared is equal to 1 minus x squared. And so therefore a is equal to the square root of 1 minus x squared. Now, as tempted as you're going to be to try to simplify that, let me just give you a heads up. That does not simplify. It's just the square root of 1 minus x squared, and that's it. So I'm going to erase my a here, and I'm going to replace it with what we just calculated, which was the square root of 1 minus x squared. And now we are going to do the sine of this angle, which is opposite over hypotenuse. And so the opposite side is going to equal to square root of 1 minus x squared. The hypotenuse is going to be 1, so over 1. That doesn't really do anything, and so what you end up getting is the square root of 1 minus x squared. Okay, last example here in section 4.7, and then we'll be finished learning about inverse trig functions. This is cotangent of the sine inverse of 2x. And again, you want to think about that as being 2x divided by 1. So when I draw a picture here, here's my angle. I want the sine to be 2x over 1. And so the sine is going to be opposite over hypotenuse. And so therefore this is going to be 2x on the opposite side and 1 on the hypotenuse. Now I'm going to call this bottom side a just as a filler for now so that I can use Pythagorean theorem to solve for a. And so this is going to be a squared plus 2x squared is equal to 1 squared. And I know that 2x quantity squared is really 4x squared is equal to 1. And so then subtract 4x squared so that you get 1 minus 4x squared, and then take the square root, which is going to give you the square root of 1 minus 4x squared. And again, that is not going to simplify. Let me do you a huge favor and just save you some heartache. Please do not try to simplify that at all, because it will not simplify. And so I'm going to go ahead and put that here on the bottom of my picture, square root of 1 minus 4x squared. And now I am ready to do the outside, which says cotangent, which is the reciprocal of tangent. And so if tangent is opposite over adjacent, then cotangent is adjacent over opposite. And so the adjacent side of my triangle here, of my angle theta, is going to be the square root of 1 minus 4x squared. That will be the adjacent side, and the opposite side is going to be 2x. And so this is going to equal to the square root of 1 minus 4x squared, all divided by 2x. Okay, that's going to do it for section 4.7. So you guys, please let me know if you have any questions.